We're going to start chapter 2 today about linear equations and inequalities in one variable. The chapter starts on page 113, and we're going to start talking about some concepts of terminology that we need to understand. So we need to understand the meaning of linear first. So let's start with talking a little bit about what we covered the last time. So we were talking about exponents, and we were talking about powers in the last part of chapter 1. If you remember, we have some powers of x. I'm going to write here, powers of x. And those powers are going to depend on the exponent. So if you have just x, so the exponent is just 1. I'm going to write here. So the powers of x are x to the n. So when the exponent is 1, and usually you don't write the 1 here, so, but this is a convention that this is a variable raised to power 1. So this is the first power of x. This is the first power of x, and usually we use the word linear to indicate that we are dealing with a variable to the first power. We can have also x to the second power. So this is the second power. So the exponent here is 2, and we can say that this x is squared. So when anytime that we have this kind of variable, this kind of power, we're going to say that this is a quadratic term or quadratic equation or quadratic inequality. It depends on the context, but the important thing is that the word comes from the exponent or the power of the variable. So we have also the third power of x, which is just x cubed. So the exponent here is 3, and we use the word cubic to refer to this case, and so on. So we have the fourth power, x to the 4, the exponent is 4, and we use the word quartic, and so on. You can check in more advanced books of algebra about the different terms that we use. So this is important because anytime that you read the word linear, then you have a clue about the exponent of the variable. So we have, for example, linear terms. What are linear terms? For example, y is a linear term because y is raised to the first power. 3x is another linear term. We have negative 7z is another linear term. 8u is another linear term. The variable is u. So, and also these terms are linear terms in one variable. If you can apply the word quadratic, we can write some quadratic terms. So quadratic terms are, for example, negative 2y squared, that's a quadratic term. 4x squared is another quadratic term. Negative z squared, u squared. So those are quadratic terms in one variable. So we can use also the term linear to refer to equations. So we can have, for example, linear equations. Linear equations, remember we need the equal sign to be involved. So we can have 3x plus 2 equals to 0. This is a linear equation because the term with the highest exponent or power is this, and it's a linear term, so then the equation is a linear equation. You can have also quadratic equations. We're going to talk about quadratic equations at the last part of the semester. So quadratic equations, they have quadratic terms, but they also have linear terms, and also constant terms. So in this quadratic equation, we have a quadratic term, we have a linear term, and also we have a constant term. But what is the term that influences the name of the equation? The term with the highest power. So in this case, the quadratic term is the one that dominates the terminology for this equation. So we're gonna we're gonna read the definition of a linear equation, the formal definition that your book has, and then we're gonna start with section 2.1. So the definition of a linear equation according to your book is on page, so the definition is on page 114. So I'm going to copy the definition in the way that is expressed in your book. So it says that a linear equation in one variable x, so a linear equation in one variable x is an equation that can be written in the form, and then we have an equation ax plus b equals c, where a, b, and c are real numbers, and a is different than 0. So that's the definition of a linear equation in one variable x. So it's linear because you have the variable x written at its first power or raised to its first power, and also is in one variable because the only variable here is x. A and b are not variables, they are constants. So the difference between constants and variables is that we use, if you remember, the last letters of the alphabet to talk about variables, to express variables, and we use the first letters of the alphabet, A, B, C, D, to express constants. What is the meaning of a constant? That you assume that that letter only represents a single value, a single number. On the other hand, x is open, is allowed to represent many different values, many different numbers. That's the difference. That's the reason it's a variable, because it can change its value, or it can have different values. So we're going to start now with section 2.1. Section 2.1. Let me write this here. Section 2.1 is on page 114, and is the title of the section is the addition property. The addition property of equality. So that's the section. So what is this thing about the addition property? So in this chapter, we're going to learn how to solve equations. So our main goal is solving linear equations. So what is the meaning of that? What is solving linear equations? Is just find the values of x that satisfy the equation. So what is this thing about satisfying the equation? That the statement is true. So that's the meaning of satisfying or finding a solution of a linear equation. And we're going to use two properties to accomplish this goal. So we're going to use the addition property, and we're going to use the multiplication property. So by using these two rules or these two properties, we're going to be able to solve a linear equation. This is to find the solutions of the linear equation. We're going to use two properties. This is our section 2.1, and this is going to be our section 2.2. So what we're going to learn in this section is applicable to find solutions, but sometimes it's incomplete. So we need the other property. We need the multiplication property. There are going to be just few cases where only the addition property solves the equation, and there are going to be few cases where the multiplication property solves an equation, but most of the time you're going to need both properties. And the order in which you apply those properties is going to be very, very important. Usually we start with the addition property, and we end with the multiplication property. But there are some cases where you need to start with the multiplication property first. So let's start with the addition property then. So the addition property is defined on page 115. So, and it's just another green box in your book. So it says, I'm going to show you the book, and I just write there's the addition property of equality on page 115. The same real number or algebraic expression might be added to both sides of an equation without changing the equation solution. This can be expressed symbolically as follows. So we're going to copy that last row because that's the most important part. So the addition property then, the addition property of equality is just that if A equals B, so that's my initial equation, then we can add C to the left-hand side, and as long as we add also C to the right-hand side, the equation solution is going to be the same, so it doesn't change. So the solution for this equation is going to be the solution for this equation. So these two equations are going to be equivalent because they're going to have the same solution, and we're going to use this property usually to isolate the variable, because the solution, finding the solution of an equation is just isolating the variable on one side of the equation. So you're going to see that now. I'm going to solve the first example of this chapter. So this is going to be example 1. That example is also on page 115. And the directions are solve the equation. And the equation is x minus 3 equals 8. So that's the equation. We want to find the values of x that make this statement true. So how do you proceed? We're going to apply the addition property of equality. The purpose of applying that property is that we want to isolate. That's what we want to do. To solve the equation, we need to isolate the variable. We want to have the variable on one side of the equation and the other numbers on the other side. So we have x minus 3 equals 8. So we're going to need to add something to the left-hand side to remove this negative 3. So what we need to add is just the opposite. So if we have a negative 3, we're going to add positive 3. And if we do this on the left-hand side, we need to do it on the right-hand side. So we're gonna do this, we're gonna proceed. So this -3 with this +3, they cancel to each other. So we end up only with x on the left-hand side, our equal sign, and a plus 3 is gonna be 11. Now, the variable is isolated on the left-hand side. So that means that this is our solution. So this is the solution. We can make mistakes during the process, so we need to verify that this is the solution. So we need to test the solution. We need to test the solution. To test the solution, what you're gonna do is you're gonna evaluate the original equation, x minus 3 equals a, for the value for x that you found. So in this case, x equals 11. So, and to evaluating means, if you remember, is just replacing every x with 11 in this case. So let's do that. So we're gonna have 11 minus 3. So that's my left-hand side. Remember, when we are evaluating equations, we work both the left-hand side and the right-hand side independently. So I have 8 on the right-hand side. When we verify solutions, is what we do. So 11 minus 3 is going to be 8, and we have 8. So these are the same. So this is, we are saying that a equals 8, and this is a true statement. So that means that, yeah, x equals 11 is the solution. We're going to use the set notation to indicate the solution. So x equals curly braces 11, and that's the final answer. You could see here that when we added a value, a number on the left-hand side, we did it also on the right-hand side, and this is the most common way to do it. So the way that the addition property is written is not the similar way that we use to apply that property. So I might add here that when you have a equals b, you can add c to the left-hand side, you can add c to the right-hand side, and then you're gonna get a plus c equals b plus c. So this is the actual way that we use the addition property of equality. So we're gonna solve more problems. So we have now example 2. So let's work on example 2. Let's see. We have example 2 on page 116. And now we're gonna solve and check, because remember, it's not just getting the value for the variable, it's also verifying that the value that we obtain is also the solution. So we have now z plus 1.4 equals 2.06. So be careful with your handwriting. Sometimes we don't pay a lot of attention to that, and we can make mistakes just because we can use take some variables by numbers. So for example, if you don't write your z correctly, at some point you might think that this is the number 7, and then yeah, you miss the variable. So here we want to remove 1.4 from the left-hand side, so we need to add, in this case, a negative number, because that's the opposite sign. So we're gonna add always the number with the opposite sign, and we're gonna add that number on both sides of the equation, or to both sides of the equation. So if we do that, we cancel this because they have opposite signs. This is the same number with the opposite sign. So you end up with z, and in this case, we need to proceed with this subtraction. So we're gonna see that the answer is gonna be 0.66. So you can use your calculator or you can do your work by hand. So that's the solution. Now we need to test the solution. So we're gonna evaluate the original equation, z plus 1.4 equals 2.06 for the value of the variable that we found. So that means that we're gonna replace z with 0.66, and then we're gonna finish this work. So this is on the left-hand side. You proceed and use your calculator, and you're gonna get 2.06, 2.06. Are they the same? Yeah. So that's true. So that's example 2. Let's work on more examples. So I'm going to work now. Example 4, where you need to combine like terms. So example 4 is on page 117. And in this case, we're gonna solve and check again. Solve and check. So the equation that we have is 5y plus 3 minus 4y minus 8 equals 6 plus 9. So this is a linear equation in one variable because the variable is the same, is y. Is linear because the y is also raised to the first power, and there are no other terms with higher powers. So to solve this, the first thing that we need to do is we need to combine like terms first. So what are the like terms? 5y minus 4y. So we have 5 minus 4 is going to be 1. You can write 1y. And then you end up with plus 3 minus a equals 6 plus 9. Now we're going to combine the constant terms. On the left-hand side, we have these two. If you combine them, you get 3 minus 8. You subtract, or you do a minus 3 is 5, and keep the sign of the number with the highest absolute value, or greatest absolute value, and 1y is just y. You don't need to write the number 1. If you want, you can do it. It's fine. There is no problem by doing that. Also, 6 plus 9 is just 15. So now we have this equation. This is the linear equation that we're gonna be used to see to solve. So then we apply the addition property. So we apply the addition property, meaning that we need to isolate y. So we're gonna add 5 to both sides of the equation. Why? Because I want to remove this negative 5. So I need to add the opposite. Since I have negative 5 here, I need to add positive 5. By doing that, these two constant terms cancel to each other. So I end up with y equals, then 15 plus 5 is going to be 20. So this is the solution. Now we need to test the solution. So we're going to test the solution. So we're going to evaluate the original equation. So 5y plus 3 minus 4y minus a equals 6 plus 9 for y equals 20. That's what we're going to do. So we're going to replace every y with 20. So there are two places we're going to do that. So we're going to have 5 times 20 plus 3 minus 4 times 20 minus 8. And this is equal to 6 plus 9. So let's see. So the right-hand side is easy, it's just 15. What about the left-hand side? So we have 5 times 20, that is gonna be 100 plus 3 minus 4 times 20 is gonna be minus 80 minus 8. Then we can combine first positives and negatives. So if you combine positives, you get 103. If you combine negatives, you get negative 88. And finally, you just need to end this operation. So you can do it by hand. You can do it by using your calculator, and you're gonna find 15 equals 15. So this is true. So the solution is y equals 20. So, and here we've missed doing the same thing. We needed to write z equals 0.66. So don't forget the set notation for the solution. So in this case, y equals 20. So let's see, you're gonna have your first set. Then we're gonna continue with the next section. So you're gonna solve exercises from 2.1 exercise set. Let me write the problems for you. So if you solve a lot of problems, you're gonna get a better practice on solving equations. So I know that I'm going to ask you to solve at least to turn in the one that I'm going to start, but it's better if you solve all of them, because that way you're gonna get a better understanding of the procedure. So 2.1 exercise set is on page 120. So we have these problems for you. We have problem 12. So the directions are solve and check. So y minus 5 equals negative 18. Then we have problem 16. Negative 13 equals 11 plus x plus 11. So it doesn't matter whether you get your variable on the right-hand side at the end of your process. As long as the variable is isolated is what matters. So then we have problem 22, negative 8 plus y equals negative 29, and finally 46 is negative 3x minus 5 plus 4x equals 9. So at least get me the answer for the last two. So that's the first section. So I'm going to give you some time to solve these 4 problems and prepare for the submission. And then we're going to continue with the next section. We're going to start now section 2.2 on page 122. And this section is about the multiplication property of equality. So I mentioned a moment ago that we need 2 properties to be able to solve linear equations. The first one that we studied in the last section was the addition property of equality. And now we're going to study the multiplication property of equality. You're going to see a green box on page 123, and you're going to find there the description or the definition of that property. The same non-zero real number or algebraic expression might multiply both sides of an equation without changing the solution. This can be expressed symbolically as follows. So if you have a equals b, and you have a number that is not a zero, then you can multiply both sides, and the solution is not going to change. So we're going to write this. It's on page 123, and it's just the multiplication property. It says that if A equals B, so that's my original equation, and we have a number that is different than 0, then we can multiply both sides of the equation by that number. So we're gonna multiply this by C, we're gonna multiply this by C, so we're gonna get A equals BC, and the important thing is that the solution for this equation is gonna be the same solution that you're gonna get for this equation. So these two equations are equivalent equations, so meaning that the solution doesn't change if you multiply both sides of the equation by the same number. So we're gonna start with an example, and this example is very important because it's gonna be the example that is gonna indicate when you should start with the multiplication property. I said before that most of the time we're gonna start with the addition property, and we end up using the multiplication property to isolate the variable, but there are few cases where you need to start with the multiplication property. This is one of the cases, so it's good that this case is the first example that we're gonna solve. So you're gonna learn how to identify a problem that requires the multiplication property first. So we're gonna solve this equation. It's on page 123 and is x over 5 equals 9. So what is that case where you need to apply the multiplication property? Is when you have denominators. If you see your equation and there are denominators, don't think twice. You have to start with the multiplication property. So the multiplication property in this case is very useful because you're gonna remove the denominator. So you're gonna apply the multiplication property to remove denominators. So this is important. If your equation has denominators, first property to be applied, the multiplication property. So you're gonna multiply by the denominator that you want to get rid of. So I want to remove 5, then I need to multiply by 5. So that's the rule. If you have a denominator and you want to remove it, then multiply by that denominator both the left-hand side and the right-hand side. So I'm multiplying both the left-hand side by 5 and the right-hand side. Both the left-hand side and the right-hand side by 5. So if I do that, then I'm going to be able to remove this denominator because these two cancel to each other. So I'm not going to use a diagonal to indicate that I'm canceling. I'm just going to put an arrow indicating that they are going away. So they are going away. So you're gonna end up with x only on the left-hand side, and you end up with the product on the right-hand side. 5 times 9 is gonna be 45. So this is my solution. I need to verify that this is the solution. So we're gonna need to test our solution. How do you test a solution? Remember, you're gonna evaluate the original equation for the value that you just found. So to verify this, then you're gonna replace the x with 45 in this case. So you're gonna replace x with 45 over 5. So this is equal to 9. We worked the left-hand side and the right-hand side independently. So 45 over 5 is gonna be 9. 9, are these equal? Yeah, that's true. So that means that x equals 45 is the solution for this equation. But yeah, remember in this case, also the other message is that if you have denominators in your equation, apply the multiplication property and get rid of those denominators. If you have many denominators, you might need to multiply many times. So you first eliminate one denominator, then you move and remove another denominator, and so on. Or if you know how to compute the least common denominator, you can do it in one single multiplication. You just multiply by the least common denominator both sides of the equation. So let's work another example. So this is example 2. Let me write this here. So we have example 2. Example is on page 124. This is page 124. We're gonna solve. The first problem is just 6x equals 30. So now we need to solve for x. So in the previous example, we learned how to remove denominators. Now we're gonna remove coefficients. So the multiplication property. So we're gonna use the multiplication property. We're gonna apply the multiplication property to remove coefficients. So I want to remove this 6 here. So I don't want that 6 because I want the x completely alone. And that's the solution for x. So to remove coefficients, we use also the multiplication property. We're going to divide, but remember, dividing is multiplying. So remember, the division is just another way of multiplication. So when you apply the multiplication property to remove coefficients, you divide by the coefficient that you want to remove. So divide. You're going to divide both sides, okay? Divide by the coefficient both sides. So if I have 6x equals 30, I'm going to divide by 6 here, and I'm going to divide by 6 the right-hand side. So by doing that, you're able to cancel these two. So you get x equals 30 over 6 is going to be 5. So remember, you want to remove denominators, you multiply by the denominator that you want to remove. You want to remove coefficients, you divide by the coefficient that you want to remove. So the rules are very simple. So it's just a matter of practice that you're going to memorize these rules. If you need them in your formula sheet, you are free to do so. So you're going to test these solutions at home. I'm going to continue with the next problems. Remember, you need to check. We're not going to spend time on that because we need to cover more examples. So the next example is negative 7y equals 56. This is the coefficient I want to remove. So that means that I'm going to divide both the left-hand side and the right-hand side by the coefficient I want to remove. I want to remove this negative 7, not just the 7. I also want to remove the negative sign. So that's the reason I'm doing this. Now you need to remember that in this case, they are the same, you just remove them. And in the other case, on the other hand, you need to check sign. So positive divided by negative is going to be negative. 56 divided by 7 is going to be 8. So that's the answer. Y equals negative 8. You need to check this later. So we have one more exercise. Now we have negative 18.9 equals 3z. What is the coefficient? The coefficient is here. This is the one I want to remove. This is the one to be removed. This is the coefficient to be removed. The coefficient to be removed. So these are the coefficients to be removed. So I need to apply the multiplication property. So I have 3z. I need to remove only 3. You don't divide by z. Some people also write 3z's. If you do that, you also remove the variable. So you divide by 3 both sides of the equation. So if you use your calculator or do it by hand, you're gonna find that this is negative 6.3, because negative divided by positive is gonna be negative, and in the other side you're just gonna get z. Why? Because the number 3 on top cancels the number 3 at the bottom. So that's example 2. We're gonna solve another example. So we have now example 3 on page 124. So we're gonna solve a couple of exercises. So the first one is 3/4 of y equals 12. So now we have a coefficient that is a fraction. You can divide by that coefficient, but it's going to be a little bit complicated because it's a fraction. So in this case, it's better if you split the process in two parts. First, focus on the denominator, because it's what I said before. If you have denominators, that's your first step. Remove the denominator. So in this case, you're going to remove the denominator first. So how do you remove the denominator? We're going to remove the denominator by multiplying both the left and the right-hand side by that denominator. So the denominator is 4. I need to multiply by 4 both sides. If I do that, you know that in the left-hand side, you remove these two pieces from your equation. They vanished. So you end up with 3y only on the left-hand side, and you get 48 on the right-hand side. Now, the next step is we need to remove the coefficient now, because remember, we are isolating the variable. So we have 3y equals 48. We're going to divide this by the coefficient that I want to remove. The coefficient is 3, so I need to divide by 3 both sides of the equation. So if I do that, this remove, and I end up with 48 divided by 3. So y is going to be 16. So then you check. Remember, you're going to do your testing, especially if you are taking a quiz or exam. If you are taking a quiz and you failed, you have another attempt. But if you are taking your exam, don't take risks. Check your solutions before submitting your answer, because once you click your answer, you submit button for the exam, you cannot change anything. So that's part A. Now let's work one more case similar to this one. So this is going to be part B. And part B is 9 equals negative 3 over 5x. Again, we have denominators. We have a denominator to remove, so remove denominators first. I'm going to write this many times for you to remember. So we have this. What is the denominator? The denominator is 5. I need to multiply by 5, both the left and the right-hand side. By doing that, I can get rid of these two. So I'm going to get 45 equals negative 3x. What is the next step? Remove coefficients. So in both cases, we are applying the multiplication property. So we're going to divide. So I'm going to write again my equation just for you to see the step. I'm going to divide by the coefficient. The coefficient is -3. I need to remove the negative sign too. So if I do that, here and here, we are fine because we end up with x only on the right-hand side. X is alone. Now 45 divided by 3 is 15, and positive divided by negative is negative. So this is the solution. You're going to check and test that this is correct. So it doesn't matter that you get your x on the right-hand side. You just can flip the expression and you get now the x on the left-hand side. But this is the same. It doesn't matter. So we have now one more example, and then you're going to have your exercise set. So this is example 4. Example 4 on page 125. So we're going to solve negative x equals 4. So here we have a negative sign. How are we going to remove the negative sign? So you can write this as negative 1x equals 4. Remember, coefficients of when you don't see a number is just 1. Exponents, the same thing, you have a 1 here. So now it's very easy. You want to remove the coefficient, just divide by the coefficient. So you have negative 1x. You're going to divide by the coefficient that you want to remove. So if you do that, you get x equals positive divided by negative is negative. 4 over 1 is just 4. So x equals negative 4 is the solution for this equation. Another way to see this is that if you change the sign of every term in your equation on both sides of every term, in this case, you're going to get the solution because this negative x becomes positive. This positive 4 becomes negative. That's another rule. But if you want to apply the multiplication property, it's better because you understand what you are doing. So the next problem is negative x equals negative 7. So we're going to do the same trick. We're going to write negative 1x equals negative 7. Then we're going to divide both the left-hand side and the right-hand side by the coefficient that I want to remove. I want to remove this coefficient, negative 1. So if I do that, then I'm going to get x on the left-hand side. Here you're going to get negative divided by negative is going to become positive. 7 over 1 is just 7. So this is the solution, x equals positive 7, and that's the same thing. If you just change the sign on the left, you need to change the sign on the right, and you get x equals 7. So this is the examples that you need to be able to solve now. Exercises from the second set of problems. So we're going to have now, maybe I'm going to give you just a couple of problems. So this is right here, 2.2 exercise set, page 130. So you're going to solve. So you're going to solve problem 2. It's just x over 7 equals 4. Then you have problem 4 plus x over negative 5 equals a. Then we have problem 6. 6y equals 42. Then you have problem 10. That's negative 36 equals 8. Z Then problem 16 is negative 16y equals 0. Problem 22 is just negative x equals 23, and problem 28 is going to be ax minus 3x equals negative 45. So I want you to solve problem 2, problem 16, and problem 28. So those three problems at least. You are welcome to solve all of them, right? And more, if you check the book, you're going to find more problems. So I'm going to give you, let's say 5 or 10 minutes, work on that, and then you can continue watching the video. Now we're going to apply both properties, because I mentioned before that having to apply only one property is just not common. So most of the time you need to apply both properties. So on page 126, you're going to see this part of the section that says equations requiring both the addition and multiplication properties. And you can see on example 5 that 3x plus 1 equals 7 is just the equation, the linear equation that most of the time we're gonna need to solve. So we're gonna need to work on this by following the steps that you just learned before, but now I'm showing you the steps in a more organized way. So first, you're gonna remove the denominators. So anytime that you remove the denominators, that's the multiplication property. Sometimes you don't have denominators, so you just go directly to step 2. Step 2 is, and you need to read carefully. In step 2, I'm saying isolate the term containing the variable. In the third step, I say isolate the variable. So there is a difference. Isolate the term containing the variable. You're going to apply the addition property, and your aim is just to get the term containing the variable. So you still have a coefficient to remove. So in the last step, you're going to isolate the variable by removing its coefficient. How? By using the multiplication property. So we're going to solve some examples, and then with that, we're going to finish the section. We have one more section for today's lecture. It's going to be a combination of these two first sections. So we're going to work on example 5. Example 5 is on page 126. So in this example, we're going to solve the following equation. 3x plus 1 equals 7. So first, you can check that there are no denominators. To remove the no denominators are present. So nothing to remove. So we go directly to, we're going to isolate the linear term. So we're going to isolate the linear term. What is the linear term? This is the linear term. So it's the term containing the variable. We need to isolate that term. How? You're going to apply the addition property. To isolate this term, I'm going to write it here, 3x plus 1 equals 7. To isolate this 3x, we need to remove this 1 here. So it's positive 1, we need to add negative 1. So that's the addition property. So be careful. So if you do that, these two constant terms cancel to each other. So you end up with the linear term. So the linear term contains the variable, but still contains a coefficient. So 7 minus 1 is going to be 6. So now the last step is we're going to isolate the variable. So you need to be careful. You first isolated the linear term. Now we're going to isolate the variable. So now we're going to apply the multiplication property. So in this case, we have 3x equals 6. We need to divide by the coefficient that we want to remove. We want to remove this 3. So we divide by 3 both sides of the equation. So that allows us to get rid of these numbers here. So this vanish, this vanish, this vanish, this vanish. So we end up with x only on the left-hand side, and we got here 2. So that's the solution. Remember, you need to check your solution. We're not going to spend time on verifying the solution. You have to do it by yourself. So you're gonna find that x equals 2 is the solution for this equation. So now we're gonna work example 6. Example 6 on page 126. So we're gonna solve another equation. This equation is negative 2y minus 28 equals 4. So the first thing that we see is that there are no denominators to remove. So we go directly to the second step. We're going to isolate the linear term. So what is the linear term? This is the linear term. So I need to get the linear term alone. So I need to remove this part of the left-hand side. So it's negative 28. I'm going to eliminate that by adding 28. So I'm going to apply the addition property. The addition property. So with that, we cancel this. So we end up with negative 2y equals, in this case, we're gonna get 32. So 4 plus 28 is 32. The last step is just, we're gonna isolate the variable. So we're gonna remove its coefficient. How? We're gonna use the multiplication property. So we have negative 2y equals 32. We're gonna divide by the coefficient, which is negative 2. So that allows us to remove this negative 2 in front of y. And we end up with only y on the left-hand side. And 32 divided by negative 2 is going to be negative 16. So that's the solution. You need to verify that. So you're going to be able to write this y equals negative 16. So we have one more problem. This is example 7. And what we are doing now is just a preparation for the next section, because the next section is going to cover everything that we covered in the first two sections and a little bit more. So we have example 7 on page 126. No, 127, sorry. We're going to solve the following equation. 3x minus 14 equals negative 2x plus 6. So you can see that you have linear terms on both sides of the equation. So the first thing is, the first thing is checking whether you have denominators. There are no denominators, so no denominators. So there are no denominators. So we go directly, and now we're going to combine like terms, because we have linear terms on both sides of the equation. So we're going to need to use the addition property to combine like terms. So this is important. That's another useful application of the addition property. So I have 3x minus 14 equals negative 2x plus 6. So I want this negative 2x to be on this side to be able to combine it with 3x. So what I'm going to do is going to add 2x, because by doing that, I'm going to remove this linear term from the right-hand side, and then it's going to show up on the left-hand side. So that's the first step. I'm adding 2x on both sides of the equation because I want all the x's on the left-hand side. So if I do that, I'm going to get 5x, and in this case, this and this cancel. So you remove them from here, and you write what is remaining. So you have to write the negative 14 equals 6. Now you have an equation that's like the one that we have before. So now our third step is just isolate the linear term. So we're going to have to add 14 on both sides of the equation to be able to get only 5x here. Remove negative 14 by doing this, so you get 5x equals 20. Now in the last step, we're going to isolate the variable. How? We're going to use the multiplication property, so we're going to divide by 5 both sides of the equation. So in that way, now you get rid of this 5. So you end up with only x equals 20 divided by 5 is going to be 4. So you're going to check this. So you're going to be able to prove that this is the solution for this problem. So I think now it's going to be the time for you to work on more exercises to be ready for the last section that we're going to cover today. So we're going to go back to 2.2 exercise set on page 130, and you're going to solve the following exercises. So there are just 8 equations to solve. You're going to at least solve 3 or 4. Let's see. So we have problem 30. 2x plus 5 equals 13. Problem 32 is 3x minus 2 equals 9. Then we have 34 is just negative 3y plus 4 equals 13. 36 is just negative 2y minus 5 equals 7. Then we have problem 38 is just 14 equals 5z minus 21. Problem 40 is just negative x, negative 5 equals 5. Problem 42 is just ay equals 3y minus 10. And 46 is negative 7x equals negative 3x minus 8. So work at least these 3 problems and prepare your work to be submitted at the end of the lecture. So I'm going to give you again 10 minutes to work on this, and then we're going to continue with the last part of this lecture. Let's finish this lecture by working on section 2.3. It's about solving linear equations. It's just a collection of the information that we just learned from the previous 2 sections. So this is on page 132. And if you check the bottom part of this page, you're going to find a green box with the steps that they suggest to follow to solve a linear equation. The step-by-step procedure is given here. So they talk about simplifying the algebraic expression on each side first, then collecting all the variable terms on one side and all the constant terms on the other side. Then we're going to isolate the variable and solve. And finally, we're going to check the proposed solution in the original equation. So I just rewrote these steps in a way that is using the terminology I have been using during the explanation of the previous two sections. So you have here another way to say the same thing. So solving linear equations, we're going to start by simplifying the algebraic expressions on each side. So this is similar to the first step on your green box. So simplify is the key component here. Then we're going to combine linear terms. So we're going to focus on the linear terms first, the linear terms. So we're going to collect them, all the linear terms on one side. That's our first, that's our second step. Then we're going to isolate the linear term by using the addition property. Remember, we're going to isolate the variable by using the multiplication property, and then we're going to test the solution. But before all these steps, we have a step 0 that is not in the book, but is in our previous notes. What is the step 0? If you remember, the first step is the step 0. It's 0 because many times you don't have to do this step. But there are some cases that we need to start with this 0 step, is remove denominators first. Remove denominators first. So by using the multiplication property. It's not given here, but because most of the time we don't have fractions, but when you have fractions, everything should be after, so everything should be done after removing all the denominators. So you can need sometimes use the least common denominator or just remove one denominator at that time. So we're going to start solving some examples. This is just more of the same because we're going to repeat the same steps that we repeated before. So especially in the last part of the previous section. So this is going to be my first example from this section. So this is example 1. Example 1, page 133. So this is one more opportunity for you to understand this crucial procedure in algebra. You need to know how to solve linear equations to pass this class. So in your first exam, this is a crucial component. So we're going to start solving. We're going to solve and check. So what is the equation? The equation is 2x minus ax plus 40 equals 13 minus 3x minus 3. So that's our first equation. So the first step is checking our 0 step is checking denominators. There are no denominators, so step 0, no denominators. So that's fine. We start right away with the first step. We're going to simplify. So simplify means that you're going to collect like terms. You're going to combine like terms on each side of the equation. So you combine like terms on each side of the equation. So that's step 1. So in this case, we have, these are like terms. So 2x minus 8x. So it's 2 minus 8 is going to be minus 6x plus 40. Then we're going to combine like terms here. So 13 and negative 3. So 13 minus 3, this is going to be 10. And then the remaining term is negative 3x. So we combine like terms. So now our next step is just we're gonna collect the linear terms on one side. So we need the linear terms on one side. How are we gonna do that? By the addition property. So we're gonna, in this case, we need this term, this linear term on the left-hand side. So we're gonna add 3x, we're gonna add 3x. So that's the second step. So negative 6 plus 3 is gonna be negative 3x plus 40. And this is gonna be equal to 10 because these two cancel to each other. So negative 3 and positive 3, they vanished. So now, the next step is we're gonna isolate the linear term. So we want this term to be alone. So to do that, we're gonna remove this 40, is positive, so we're gonna add negative 40 on both sides. So this is to isolate the linear term. So we're gonna get just negative 3x because this positive 40 and this negative 40, they are gonna cancel to each other. And then we're gonna have here 10 minus 40 is gonna be negative 30. So then the next step is we're gonna isolate the variable. To isolate the variable, now we need to divide by the coefficient that we want to remove. We want to remove negative 3. So we're gonna divide by negative 3 both sides of the equation. So negative 3, they are removed now. So I end up with x equals negative divided by negative is going to be positive. 30 divided by 3 is going to be 10. So this is the proposed solution. So we're going to test the solution. So by evaluating the original equation, 2x minus ax plus 40 equals 13 minus 3x minus 3 for the proposed solution, which is 10, meaning that we're going to replace every x with 10. So there are three locations, 3 places where x is going to be replaced by or with 10. So it's going to be 2 times 10 minus 8 times 10 plus 40. That's the left-hand side. The right-hand side is 13 minus 3 times 10 minus 3. We don't use the equal sign because we're going to verify that actually the both sides are going to be equal. So 2 times 10 is going to be 20 minus 80 plus 40. Here we're going to have 13 minus 30 minus 3. So remember, we combine positives first. So 40 and 20 are 60 minus 80. Here we combine 2 negatives. So 13 is positive, 30 and 3 is going to be 33, but they are negative. And finally, we end up with the subtraction. So on the left-hand side, we're going to get negative 20. On the right-hand side, we're going to get negative 20. So, yeah, that's true. So that means that x equals 10 is the solution. So we use the set notation. So that's example 1. So let's continue. We need to work a lot of examples because this is a crucial part of the semester. Example 2 is on page 133. If you have questions about the problems that you're gonna have later to solve, you can email me and I can give you, I can check your work. And I can give you clues or ideas on how to solve your problem. So we're gonna solve uncheck 5x equals 8x plus 3. So no denominators. Perfect. Then we're going to simplify each side. We're going to simplify. In this case, the left-hand side is fine. The right-hand side, we need to apply the distributive property. So a times x is going to be ax, and a times 3 is going to be 24. So now we're going to collect the linear terms on one side. So we're going to collect the linear terms on one side. So in this case, I'm going to move this ax to the left-hand side. How? You just need to add the opposite. So I have positive a. I'm going to add negative ax. So I'm going to get negative 3x equals, in this case, 24. Then isolate the linear term is our next step. It turns out that our linear term is already isolated. So we go directly to the next step. We're going to isolate the variable. So to isolate the variable, we're going to divide by the coefficient that we want to remove. So in this case, negative 3. That allows us to remove this. So you're going to get x equals positive divided by negative is negative, and negative 8. So this is the solution. So the next step is testing the solution. We are doing the entire problem because that's what you need to do from now on. So we're gonna test. Maybe here, let's see. We're gonna test. So we're gonna evaluate 5x equals 8 times x plus 3. 4x equals negative a. So we're gonna replace x with negative a. So it's gonna be 5 times negative a. This is gonna be equal to 8 times negative a plus 3. And then we're gonna proceed with the process. So I have 5 times negative a on the left-hand side. I have 8 times negative a plus 3 on the right-hand side. So this is gonna be negative 40. Here I have a times negative a plus 3 is gonna be negative 5. So it's gonna be negative 40. Negative 40 is equal to negative 40, so that's a true statement. So the solution is x equals negative a. So now we have one more problem. We have two more problems. That is going to be the end of the lecture for today. So let's work on the last two problems. We have example 3 on page 134. So we're going to solve and check again. Solve and check. So we have 2 times x minus 3 minus 17 equals 13 minus 3 times x plus 2. So this is on page 134. So let's start with the first no denominators. Perfect. No denominators. So we're going to start with, we're going to simplify each side. So we're going to apply the distributive property here and here. So we have 2 times x is going to be 2x. 2 times -3 is going to be -6. And then I have -17 equals 13. And now -3 times x is -3x. Negative times positive is negative. 3 times 2 is going to be 6. Then we combine like terms. So in this case, we have -6, -17. That is going to be -23. And I have 2x here. Then on the right hand side, I'm going to combine these two. So this is 13 minus 6 is going to be 7, and then I have -3x. So that's the end of the simplification. Then the next step is we're going to collect the linear terms on one side. We're going to collect the linear terms on one side. So I'm going to work always with the term that is on the right hand side. I'm going to remove it. So I'm going to add 3x on both sides. So 3 plus 2 is going to be 5x minus 23 equals 7, because these two cancel to each other. So I have now the equation in the way that you used to have it in the previous section. So the next step is we're going to isolate the linear term. So to do that, we're going to add 23 to both sides of the equation. So I'm going to get just 5x on the left-hand side. That's my linear term. And I'm going to get 30 on the right-hand side. Finally, to get the solution, I'm going to isolate the variable now. Only the variable, meaning that we need to remove the coefficient. The coefficient is 5, so we need to divide by 5 to be able to remove the coefficient. So I'm going to end up with x equals 6. So now I'm going to do the testing. The test is just going to be evaluating the original equation for the proposed solution, x equals 6. So we're going to replace every x with 6. So we're going to get 2 times 6 minus 3 minus 17. That's the left-hand side. We're going to have 13 minus 3, 6 plus 2. That's the right-hand side. Just do this operation. 6 minus 3 is going to be 3. So we're going to get on the left-hand side, 6 minus 17 is going to be negative 11. So that's my left-hand side. Now the right-hand side, I have 13 minus 3 times 6 plus 2 is going to be 8. Then I have 13 minus 24. And then you just do 13 minus 24 is going to be negative 11. So that's true. So we know now that the solution is actually 6, this one. Don't forget. Don't write this as the solution, because some students write this number as the solution. That's not the solution, that's the test. So the solution was the value that we used to evaluate the original equation, and that was yield to a true statement. So now we have a problem, the last problem for this lecture and for this section too. So that is going to be example 4. So we have example 4. So example 4 is on page 135. So we're going to solve and check. The following equation. So it's just 3x over 2 equals x over 5 minus 39 over 5. So we're going to start with, we need to remove denominators. So this time we have denominators. So we're going to start by removing denominators. We can remove one by one, or we can remove we can remove all of them at once. So if you want to remove all of them at once, you need to find the least common denominator. So the least common denominator here is going to be 10. It's just 2 times 5. So if you multiply by 5 both sides of the equation, you're going to get rid of both denominators, all the denominators at once. But you can also do it one by one. So let's see that we want to remove first this denominator. So we want to remove 2 first. We will remove 2 first, this denominator. We're going to remove denominator that is equal to 2 first. So I'm going to multiply every term by the denominator I want to remove. Every term. So you can see here I'm multiplying everything by 2 because I want to remove 2. So if I do that, I know that these 2 are going to be out of the equation. So I'm going to get the x. I'm going to get 2x over 5. And I'm going to get 2 times 39 over 5. 78 over 5. I still need to remove another denominator, so I'm going to remove 5. Now, okay, so that's the other denominator I need to remove. So I'm going to multiply by 5 everything. So this is going to be 2 times 2x over 5 minus 5 times 78 over 5. So you just be careful. I'm removing this denominator. They just need to be gone. So I'm going to get now 15x equals 2x only. So don't multiply by 5. Some people remove the denominator and they still multiply by 5. No. You need to cancel both value in the numerator and the denominator. The same thing here. You're going to write negative 78. Some students still multiply 78 by 5 and just remove the denominator. That's not the right way. So anytime that you remove the denominator, you're removing something also in the numerator. So that's the equation without denominator. So we remove 2 and we remove 5, the denominators, okay? So we are removing denominator. So this 2 is a denominator and this is another denominator. So I need to write this is a denominator and this is also a denominator. So the denominators I just remove. So now we're going to simplify. That's the next step. Simplify. There is nothing to simplify here. Then we're going to collect the linear terms on one side. So I'm going to move this 2x to the left-hand side. So I'm going to end up with 13x equals negative 78 because these linear terms vanished. So now the next step is we're going to isolate the linear term. It's already isolated. So in this step, we also isolated the linear term. So it's already isolated. So we move to the next step. We're going to isolate the variable now. So to isolate the variable, we're going to divide by its coefficient. So in that way, we're gonna remove the coefficient. So we end up with x only on the left-hand side, and we're gonna use our calculator, and you're gonna find that this is equal to -6. So that's the proposed solution. The last step is we're gonna test the solution. So we're gonna evaluate the original equation, 3x over 2 equals x over 5 minus 39 over 5 for x equals -6. So we're going to replace every x with -6. So there are x's in two places. So we're going to write 3 times -6 over 2. That's the left-hand side. And we have -6 over 5 minus 39 over 5 on the right-hand side. So let's see, on the left-hand side, you just multiply this. 3 times -6 is going to be -18 over 2. You proceed with the division, and you're going to get -9. Now, on the right-hand side, we have two fractions with the same denominator. So we're going to write the common denominator, and we're going to write the numerator. So now we are adding two negative numbers here. So -6 and -39. So you add the absolute values is 45, and you keep the common sign, and you have the denominator. So what is 45 divided by 5 is 9, and also the sign is negative because negative divided by positive is negative. So this is true. So that means that the solution is this one, the one that we were testing. That's the solution for this problem. So I'm going to give you 5 more problems only. You better work on those problems. This is like a test. This is just a preparation for your test next week. So you're gonna work on these problems, all of them. It's important. They are on page 141. So this is 2.3 exercise set on page 141. So you have problem 4 is 3x plus 2x plus 64 equals 40 minus 7x. So you're gonna solve and check. Then we have problem 12 is 20 equals 44 minus a that multiplies 2 minus x. Then problem 20 is 3 times 3x minus 1, and this is equal to 4 times 3 plus 3x. Then problem 28 is just 100 is negative x minus 1 plus 4x minus 6. Remember, you can write a 1 here in front of these parentheses to apply the distributive property. And the last problem is just one that involves fractions. So you have y over 12 plus 1 over 6 equals y over 2 minus 1 over 4. So this is your work. So you're gonna turn all these problems to me as your classwork assignment. So this is gonna be the end of classwork 2A. So take screenshots of all your work, create a PDF file by using CAM scanner or PDF scanner, and submit that file by clicking the submit button in the corresponding classwork page. And if you have questions, send me an email. I used to check my email very often. So maybe every 2 or 3 hours, I'm checking my email. So, and sometimes if you just send me a screenshot of what you are doing, it's better for me to understand where you are making some mistakes, or you need to do an extra step.